Hello, my name is Pradyumna Prasad. I am the Principal Software Architect at ASF UDM. I am here at the core user group to demonstrate the following items. The agenda today is lifecycle management improvements with Nokia Advanced Register CNF, authentication and identity management as a service for third-party applications, product testing with operators, test subscribers, and design automation possibilities in network planning. What is NG SDM and why is it required? Currently, there are a lot of CNFs that are being deployed, and most of these CNFs have got a lot of common components, and all these common components have a lot of common configurations. These configurations need to be made n number of times depending on how many CNFs are present on the network. Design planning and LCM activities take way too long. Now, what Nokia is doing about it is that we are going to create a single CNF called the Nokia Advanced Register CNF, and this CNF is going to reuse most of these common components. Each of the network functions, the 3GPP network functions, are going to be reduced to just microservices and not going to be separate CNFs anymore. How does this benefit the customer? This provides a very simple way of introducing CNFs, or rather network functions, to a CNF. The LCM activity is really fast because it is as simple as bringing up a set of deployments and taking them out when they're not required, or even performing upgrades and rollbacks on them. It also reduces the maintenance cost because the overall number of CNFs for management is much smaller. To give you a visual representation of how things are today, we have multiple CNFs, and we have just picked 3 of them to demonstrate the use case here. You can see that these blue boxes are representations of all the common components, and there are multiple such common components across the CNFs. Where we are heading is to something that looks like this, where we have a bunch of common components which are being used by all the network functions. Each of these network functions are just a set of deployments, right? A set of stateful sets and deployments which can be managed independently. To demonstrate how fast LCM activities can be going with this model, we have a base installation of ASF UDM with all the common components and also the integrated ZTS. Also note that the integrated ZTS is now part of our CNF, and it's not a standalone entity, which also means that addition and removal of services does not require additional activities on the integration towards the OM and the NMS. For this use case, we have chosen a network function called AANF, which will also be used in future demos. So we are just looking at how fast it's going to be to add an AANF to the existing CNF. I can also show this getting added here on the actual Kubernetes cluster, where you can see that an AANF has just been spawned. Once the AANF is up and available, it is going to be able to serve traffic. The moment this becomes green, we would also see this on the GUI that it has been instantiated, and here it is. So you can see that it is green here, which means readiness and liveness are successful, and it is also up and available for functioning. Now looking at termination also is going to be just as fast. And now looking at a use case using the AANF, that brings us to the next demonstration, which is the identity management as a service. Identity management as a service is done so that 3GPP applications can leverage the secure nature of the core to provide a secure communication between the UIs and the application functions, third-party application functions. It is also problematic for each of these decentralized entities to have a constant evolution to deal with new threats and attacks. Now, what Nokia is doing about it is providing the authentication and identity management as a service via the AANF. By doing this, we as the core network anyway has to be compliant to multiple security agencies and organizations, and also organizations in different geological locations. we are always up to date, which means that our security is always going to be at the forefront. Now, as part of this, what is the advantage for the telco operator? The telco operator can use these APIs and monetize these APIs with the third-party applications, and the third-party applications themselves no longer need to maintain a heavy infrastructure to maintain their identities and their profiles and their authentication frameworks. To demonstrate this, we have a GUI which is basically showing the interaction of something like a streaming application, which could be any third-party streaming application like Netflix or YouTube or any streaming application, and for it to provide a secure communication between the service and the UE, the coarse authentication is going to be used. This was also demonstrated in the last year's CUG. So the first thing that we are going to see here is how keys are being generated as part of an authentication flow. So when the device attaches, the device, the profile for the specific device also has indications for these keys to get generated. So as you can see here, UDM has told AUSF via an authentication API that an ACMA key needs to be generated, and now along with the ACMA key, there is also going to be an identity management key, which we are calling the IAM key, to get generated at AUSF. Once this is generated at AUSF, it is sent to the AANF, and the AANF stores this for persistence in the UDSF. When the end user actually needs to log into an application, a client application on his mobile, he is prompted a window like this, which basically is belonging to the telco application. So this has to be launched by the telco apps themselves, and this is basically a credential which is shared with the end user and the telco provider at the time of probably a SIM purchase or any later point in time. So once the user logs in, using the password that has been generated, the device is also capable of independently generating the identity management keys. The identity management key is then used to encrypt a JWT, which can be seen over here in the first message, a JSON web token, and the signature is achieved using the generated key. And the key is symmetric, so what the device generates and what the core has got is going to be the same. As part of the initial establishment request, the streaming application sends this over to the core, and the core uses the stored KIAM or the identity management frame key and the KACMA to authenticate and authorize the user. Once a successful authentication and authorization is done, the key that needs to be used by the application function to secure this communication is sent back in the response. And as you can see, the streaming also is going to be secured using the key that the application function has got. Now, to run through the call flows, you can see that there is a message here, which is basically the authentication, the initial authentication. And as part of the initial authentication, we are also registering the anchor keys. The anchor keys are basically the authentication, the ones that are going to be used for authentication and for identity management. When the application retrieves these keys, for retrieving an application key to secure its communication, these keys are used to validate the JWT. So that concludes the second demonstration. The third demonstration that we have is the adaptive test suite framework. Basically, the adaptive test suite framework was introduced because of requests from multiple customers. Today, our test suite frameworks are extremely rigid in the sense that they bring in their own subscribers and they bring in their own configurations. There is no way for us to work with the subscribers that are in the live system, and there is no way for us to use the configurations that are already present on the system. We end up modifying the subscribers or adding our own subscribers and modifying configurations that suit our test case. We are also missing key integrations of customers' test cases into our framework, and we also do not allow any real network functions to be used along with the simulator except for the system under test. What Nokia is doing about this is that we are having an adaptive test case framework which can work with the subscribers of the test subscribers of the customer, and they also work with the configurations that are on the system under test. What does this enable? This enables real world testing for the customers, and it also provides a way of having extensibility in the sense that new test cases can be plugged in dynamically to this framework. For this demo, however, we will only be looking at the agnostic nature of the test cases as far as the subscriber and the configurations are concerned. Now, bringing you back to the demonstration itself, I will first execute one test case. We have a bunch of test cases here, but I will execute one of these test cases and then run through what is actually happening, because this test case execution takes some time. So when the test case is executed and the test subscribers are provided to the test case framework, the test case framework immediately fetches all the configurations and all the customer profiles from the SDL. On picking these up, it is able to now adaptively figure out the expected responses from the system under test, and it sends the request to the system under test. Once the system under test is also working with the same request and with the same set of subscribers and sends back a response, the test case framework is able to validate it. To demonstrate the nature or this agnostic nature of subscribers and configurations, I mean, you can see that the screen is split into two sections. Basically, the same test case is run with two different set of subscribers. There are differences in the subscriber profile itself, which can be seen over here in this comparison, where if you look at the AM data get, so we have the access and mobility data that is being retrieved as part of this test case would vary depending on the access and mobility information provided for the subscriber. So you can see that there are a bunch of differences here, like the additional SNSSI data, forbidden areas and area codes and so on. So the same differences in the subscriber profile are also reflected in the actual response. So you can see that the first subscriber has got area codes while the second subscriber does not. What this goes to demonstrate is that the same test case is able to work with two set of subscribers with two different characteristics, and still the test cases are passing. Right? We also have a way of skipping test cases because there are validations done by the test case itself, which are prerequisites. As long as the prerequisites are met, the test cases run. Otherwise, the test cases are skipped, which means that only relevant test cases are going to be run for any customer. The last topic that we have today is network automation. And what we are achieving with network automation is that for a given CNF, we have multiple LANs, and all these LANs have to be configured individually as of today, which increases the number of touch points. Now with this improvement that we have got in place, we eliminate the need for repeated configurations, which means that if you take an IP as an example, and the entire IP range that needs to be used by the CNF is provided, and based on accord dimensioning, the output of accord would tell you the number of actual LANs that need to be configured and the number of IPs for each of the LANs that need to be configured. The tool that we have developed automatically splits up the CIDR range, the IP address range, into smaller IP address ranges and creates the LANs dynamically. This reduces the number of touch points, and when you look at it across multiple CNFs that are present today, you are going to have a huge amount of improvement. To demonstrate this, we have a video where you would see the current state. So this basically demonstrates the current state where we have multiple configurations for each of the LANs, and all of them need to be configured, and basically there are multiple touch points for the LANs. Now with the new solution, you're only going to have a minimized set of inputs, and the automation tool is going to take care of splitting up these IP addresses into multiple LANs and create these multiple LANs dynamically. The same is also shown via the Plateau GUI, the planning tool that we use, where we are able to choose the post handling and pre-handling blocks, which is accomplishing the splitting up of IP addresses. The input looks something like this, where we have the entire IP address range that needs to be allocated and the number of IP addresses per LAN that need to be allocated. When such an input is fed and the planner is executed, you will see that all these IP addresses get assigned automatically. Okay, so all the LANs have gotten created automatically, and then you can see that each of those LANs have already been configured. So that brings us to the end of the demonstration and the topics that we have today. So what are the key takeaways that we have got from the demonstration? First of all, we are looking at reducing the costs of LCM. So the lifecycle management is going to be made much more effective. We are giving ways for the customer to monetize identity management and authentication as a service via AANF, and our test case frameworks are going to be more robust and more ergonomical to use, and they are going to be representation of the real world test cases. Well, thank you very much.